Hello, my name is Michael Godfrey, and I'm a Senior Customer Engineer here at Microsoft. In today's demo, we will be continuing our VNet, our virtual network demos by creating peerings. So in the first demo, we created a hub network and a jump virtual machine. In this next demo, we're going to create two new virtual networks that will be considered our spoke virtual networks. We will then create an app server in one of those virtual networks, and we'll look at the routes. We'll confirm that that application VM cannot communicate to the hub network and so forth. Then what we're going to do is configure VNet peering and show how VNet peering links the multiple networks together and allows communication in a hub and spoke model for the virtual machines. So back to our code. We can see we have some code ready to go. And so the first thing we're going to do is we're going to create our new networks. And so we're going to create two new spoke virtual networks. So I'll run that selected text. And so this is going to quickly create two new virtual networks in our resource group with spoke 1 VNet and spoke 2 VNet. And then they're going to be in the 10.1.16.0 space and the 10.1.32.0 space for these networks. Then what we're going to do is we're going to create a couple subnets. So our virtual networks have been created. So we'll go ahead and create our subnets. So in this case, we're going to create two subnets in each virtual network. These subnets are just like we did in the previous demo, right? We're just going to break them up into some logical spaces. So that's almost done. And so what we can do now is we can go verify this in the portal. So if we go to our resource group, we'll see that we have some new virtual networks that are coming online. So we have our spoke virtual network, and this will be in the 10.1.16 space. Okay. And we are currently building those subnets, but you can see if we give it a second, the subnets should start to appear. Alright, so sub 1, sub 2, and so forth. You'll start to see these come in. So now those subnets are fully created and deployed into our virtual networks. So we have both of our virtual networks ready to go. 10.1.32 for the second one. Right. And if we look at the subnets, we should see sub 1 and sub 2. And so now we're ready to go. Now we're ready to create a virtual machine. So in this case, we're going to go ahead and create an application VM in spoke 1. And what that's going to do is that's going to create a virtual network interface card in subnet 1 of spoke 1. And you can see that here in the code. Right? And we're going to have an Ubuntu VM that'll be up and running. The next thing we're going to do is we're going to look at the routes. And so we can do that in command line, or we'll actually go look at this in the Azure portal. So you can see the effective route table on that VM NIC. This will show you that we are able to communicate with other resources in that same VNet. Now remember, virtual networks are islands, right? So the resources will automatically have routes to other resources in that same virtual network, regardless of subnets. You could have one subnet, you could have 50 subnets, and they will have a route to all of each other. Peering is going to bridge those two networks together, right? So we're going to take a virtual network and we're going to peer it to another virtual network and allow the peering to happen. And so we can do peering in a number of ways. We can do it through command line, we can do it through peering, or programmatically with the automation tool of your choice. But this is a good demo to show you exactly how this is operating. Right, so while our VM is being built, we can go in and we can see the resource, the connected network interface. So that will be in Spoke 1. So we probably already have that network interface card built. And so there you go. There's demo app. There's app 1 for that network interface. And so we can see it's got an IP of 10.1.16.4. It does not have a public IP. Remember that network interfaces do not necessarily have to have a public IP. They are only required to have a private IP. And then what we can do is then look at the effective routes. So here I am looking at the actual network interface card. Our VM just completed building. You can see that kind of in the background with VS Code. But with our effective routes, we'll be able to see, all the networks that it can communicate to and how it can get there. So as it's trying to go to 10.1.16.0, so that would be the address space of the entire virtual network, it knows that it just needs to stay in the virtual network. The next hop out would be a default route, a quad 0, right? So quad 0 would say it's going out to the internet. So the first hit that it's going to hit is the first route that it's going to take, the path of least resistance per se, right? So as we jump into other known networks, we can see, the path to it. In this case, these are default routes that really just don't have any actual hops. So if it's going to any of these notations, it's just going to drop. So really, the first two are what it's going to actually hit. And so in our case, same address space in the same VNet, it can route to it, and then anything else, it'll just go out to the internet, and hopefully it can find that. Right? We can actually find this the same way in programmatically, so we'll go ahead and do that here. I've given you that code as well. And when you take the exam, note that the exam, the AZ700 is going to expect that you are proficient in an intermediate level of command line tools, whether that's Bash, PowerShell, ARM, Bicep, right? So this is why in the demos I'm tending to show you a little more with code base, but I also want to show you both sides of the equation with the command line, or with GUI as well in the portal. So here we are, we're going to do an Azure VM show. This is in Bash, right? And so we're doing the name of the virtual machine, the resource group. This is going to get us that network interface card details. And then what we're going to do is we're going to ask it to show us the route table. So just like I just did in the portal, we can do the same thing. We can do the same thing here in VS Code. So now we can see that that route table has come in, and you'll see that that route table looks very, very similar to what we were just seeing in the portal because it's the same information, right? 10.1.0.0/20 is VNet local, and so that can open up to anything in that virtual network, and then a quad 0 route to the internet. So there you can see that. Now that confirms that the new virtual machine that we built, App 1 in Spoke 1, has no ability to communicate with our jump virtual machine in the hub space and so forth. So what we're going to do is we're going to create some peerings. And so I'll show you how we do this in the portal as well, but just in the sake of, in the interest of time, we'll go ahead and start this code as well. So to break down the code, we'll just look at lines 89 through 91. We can see very quickly what's going on here. So in this case, we are peering our hub to Spoke 1. And so we're taking that VNet name, the hub VNet, and we're peering it to a remote virtual network, in our case Spoke 1 VNet, and we're allowing virtual network access, we're allowing forwarded traffic, and we are also allowing gateway traffic. So there are some properties that you can do. You can see here on a reverse one, right, because every peering is actually a bidirectional thing, right? So in this case, we're going Spoke 2 to the hub. So we're reversing this and we're going to the hub. we're still allowing VNet access forwarded traffic, but in this case, instead of saying allow gateway transit, we're using the remote gateway. And what that really means is the gateway subnet that we created in our first demo for our VPN gateways with either a site-to-site or an express route exist in that hub network. They do not exist in the spoke networks. So what we need to do is say, in the hub network, we will go ahead and allow traffic that's peered to use this gateway subnet. And in the remote network that we're peering, we want to say, if you need to get to the on-premises world through the VPN tunnel that we create, then I would like you to use the remote gateway. And so that's why that's there. So we can actually go and see this in a more logical standpoint. So we'll go back to our virtual network. And if we look at virtual network, we can go to peerings. We might start to see these peerings start to show up here. But we can go ahead and peer, and this will walk you through what that process looks like in the GUI. Right? So here we would give it a name, and so what's really nice about peering is, remember I just said, it's a two-way process, right? We have to peer our hub to the spoke and our spoke to the hub. Well, if you do this in the portal, it will take care of both sides automatically for you, right? So in this case, we would do spoke to hub, right? And we would select the remote network, right? So this would be hub to spoke, right? And so what I'm doing is I'm reversing the names so that I can logically understand what's going on, or that, you know, the next person who takes over for me or my network team knows what I'm doing. Then there are those three questions that I mentioned just briefly, right? So traffic to the remote network, right? Are we going to allow traffic from spoke to the hub? Now we can make the peer, but we can deny the traffic to go across. Remember, this is microsegmentation that you have full control over. Are we going to allow traffic that is forwarded to that virtual network, in our case spoke, to be forwarded on to the hub network? And then do we want to use the virtual network gateways that we're going to use when we talk about VPNs or express routes, right? So in the case of a network that has a hub, you will have to say use the virtual network gateway, and that's why this is grayed out on this network. When I select the hub network that we have, you'll see that we'll be able to, once it sees it, we'll be able to enable the gateway on our side. But this is how you would do it from a graphical manner. So. All right, so the peerings have completed, and so what I did is during the pause to catch up, I went ahead and loaded up the route table for you to see as well. So you can see here our route table has been updated now, and now we have the ability to go from, in our case, our application VM now can talk to not just the 10.1.0 space, but it can now talk to the 10.1.32 space through VNet peering, and then the quad 0 is still to the internet. So as we start to add in additional route through hybrid connectivity with our VPN and then establishing BGP, you'll start to see the route tables grow. But you can see quickly here that we were able to establish this. Now, going back, and we'll do the same thing in the GUI. So I've loaded up that network interface for app 1, and you can see, you know, 10.1.0.0 is our VNet peering, and quad 0 for internet traffic. So with that, that completes today's demo. Appreciate it, and can't wait to see you again. Thank you.